Hey guys, I am Nick and today we will be creating this squirrel noise abstract effect. I'm super busy this week, that's why I haven't recorded my face intro preview, but the reason for that is I'm preparing a huge procedural choral pack to be published on Thursday, and also I'll be doing a video how to use it, how to upgrade it. So stay tuned. It's really awesome for any sort of abstract or organic motion design, illustrations, animations, and yeah. Fun fact, this project is actually my absolutely first project I've done in Houdini, and years before I learned it from Ezequiel nicknamed Caskal on Instagram and YouTube. I'll link his tutorial in the description if you want the original technique. However, I have adapted it pretty heavily. So yeah, and cheers to Reddit user named Send Me Your Toe, who actually asked me about this tutorial, so here it is. I hope you enjoy it. Alright, so the setup here is pretty easy to replicate, and what I'm doing here, I create one instance of this effect and then I copy it with different parameters, and then in Cinema 4D I have a bit more control over the look of the splines, so that's why, yeah, I basically stripped it to be that simple. So first of all we need our geometry. In this case, let me enable this. In this case I get this model from my mini factory or Scan the World, I think. So what I do, I add a transform node so it's not that huge and standing sweet lady, and then also add a VDB from polygons, and then this VDB from polygons switch to be the fog VDB because we need the inside part of it. If you set it to distance VDB, it will be and you convert it, it will be just like a shell. So here, yeah, we need a fog VDB. I set the voxel size to be 0.05 to just maintain a bit of detail, and then I added the volume VOP. And don't be afraid of using VOPs, they are really that simple. So what I do, I try to break the density, which is in this case it's pretty uniform. I try to break it up and add a little bit of noise so it's not equal along the mesh. So I added the AA noise, and never mind these CH things, I will explain that a bit later, but those are pretty handy. And yeah, it's an AA noise, 3D input, 1D noise. Amplitude set to 0.74, roughness to 0.5, and then I add a subtract node, and in that subtract node I feed the density, the result of the noise, and the constant of 1. And what it gives me is that when let me show you, so scatter noise ratio, you can see that now it looks like really affected by noise. And then if I bring the scatter noise ratio to 0, you can see that it's uniform. So that's how I can control how much noise is affecting the density of the fog volume. After that I scatter some points, and I'm using density. So you can see here, if I set it to 1 or close to 1, you can see that our points are scattered in some sort of clusters. Then I add a connect adjacent. By the way, somebody in the comments, please write me how should I pronounce this node correctly, because I love to use it and I use it quite a lot, and yeah, I would like to know. So yeah, we drop this node. Then we have here connection type set to adjacent points, assume uniform radius is ticked off, and search radius is bind to my control null. And yeah, once again, I will take you to this controls null and why it is so great to use. Just in a second. I would like to firstly show you the setup itself. So connect adjacent points makes these little splines between points. And then we also need to add a point warp to set up our velocity, like initial movement of the points, and that's where our point warp comes in. So we need to get a position, attach that to the pos input position input of the curl noise. In curl noise, noise type is set to analytic simplex noise and amplitude set to 0.45, and the noise plugs into the add node along with the position of the geometry, and the sum is then plugged into the velocity, and this is how we get the initial push for the noise. Then we just add a solver, and in a solver we need to plug the connect adjacent pieces to the first input, and point warp we connect to the third input. And here in a point warp, let me just explain you what's happening. So we need to add a point warp and attach it to the previous frame dop, and let's get into point warp and see what's here. So here also we don't have any sort of complicated stuff. We just get the position, we plug it into the curl noise, then we plug it to the add, we plug the position to the add, like our geometry position, and then we plug that into the position of the output. And in a curl noise also you see these bunch of channel parameters, and yeah, I will talk about that too. Here basically you can check what parameters I'm using. But yeah, this effect is all about experimentation. I mean, I always say that you need to experiment, plug your own values, uncheck, check different parameters, and that's the beauty of Houdini. Alright, yeah, back to our solver. After point warp, I drop our sample node. You can experiment with this length, because basically what it does, it decreases or increases the points between the angles of the spline. So your sample segment length is set to 0.1 just in case, and then we get the output path input 3 and plug it into the ray node with the resample node. And this one is really important because basically what ray does, it projects our curl noise to our actual geometry, and that's why these lines are not escaping the initial geometry and just are like floating on the surface. So method should be minimum distance. Yeah, I think that's basically it. So yeah, check the ray to be display render, like this blue button, and then basically your setup is done already. Let's check. Yep, doing good. But as always, I really like this node called attribute blur. It just makes it even more smoother. And there's the option to use a smooth node like this. But for me, attribute blur is a bit more versatile because we have this blurring iteration, step size, and in this attribute blur node, also pin border points should be unchecked, influence type set to connectivity. I'm using blurring iteration set to 21 and step size set to 0.02. Just to visualize this thing, we can add a color node and add a ramp from attribute. Let's say attribute should be position, so P, range from 0 to 10, and just funky gradient here. And yeah, you can just try and visualize what's happening here. I will show you how to apply really interesting color gradients in Cinema 4D. So this is just to visualize it here in Houdini. So then, yeah, your basic output node and ROP alembic output and your alembic. And now let me show you the part that really saves you a ton of time. So you add your null. I will be just like describing what this control does. If you already know, you can just skip to the Cinema 4D section. So let's say controls 2. Now is just a null. It doesn't bind to any of these nodes. And now we should edit parameter interface. These two, we can make them invisible. And here we can just, let's say we need to map our float attribute. Let's say we want to map our uniform scale. So what we can do is to drop a float here. Here in a label, let's say uniform scale. Then copy and paste it here. Range, let's say our range should be from 0 to 2. Accept. And now here in our controls, we have our uniform scale. Right now it's not bound to anything, right? But if we hit on our transform, no, we actually hit on our controls. On uniform scale, we click the right button and select copy parameter. And here in the transform, we can delete this and right click this window and select paste relative references. Now you see that our statue is gone just because our uniform scale here is 0, and if I change this value, our scale is also changing. And this is really important for, let me delete channels here. We've been at 0.1. This is really important when you are dealing with parameters that are, let's say, in our point warp. Then we have the squirrel noise, or no, actually in the solver we have our setup here. Then we go into the point warp. So basically we are 3 levels deep, and yeah, it comes really handy to just map these parameters, and you don't need to go there and there and there and there. So basically, yeah, Here I mapped all the parameters that can influence the look of these splines, and yeah, I just copied it 3 times. Let me show you how it looks like. So don't forget to highlight our out. So at a 1 iteration it looks like this. At 2nd iteration it looks like this. And for the 3rd iteration it looks like this. So you can modify all these parameters, and in each of these the controls affect only the same level nodes. So yeah, and then I basically exported these into Alembic file. You can export frame range. I just exported one for this preview. And we go into Cinema 4D. And let's check what I've got here. So the beauty of this setup is that I can control a bunch of parameters of each of the lines, not like separately each line, but the things that we exported. And here let me show you the setup. So I have my Octane sky, which is basically black background, black backdrop. Octane light, which is from the top, and another Octane light, which is here. So it's pretty easy setup, but I think you're wondering how to get these really interesting color effects on the lines. So when you import the Alembic file into the Cinema 4D, it will look like nothing. So what you need to do is add a C4d Octane tag, Octane object tag, and then add a hair and tick that we are rendering this as hair. In the root thickness, I think we can go with a 0.1 and the tip thickness 0.01, and yeah, root thickness also 0.01. So yeah, basically it's already looking quite interesting, to be honest. Mainly because I also tweaked the temperature of the lights. So one of them is really warm and another one is kind of like neutral. So now, how to texture the thing. Here I have my gradient, and let me just do this sort of stuff. And now let's also get this layer smart object, convert to smart object, and filter liquify. So now let's get to twirl clockwise tool. And now we kind of just mess with it. I don't know, maybe let's use this. Hope that my laptop won't freeze. And this is how you manipulate this stuff. The messier it gets, the better, really. So just, yeah, make sure it's pretty like this. So then you hit OK and save it as a PNG. Right? So I'm using basically 2 textures. So I want to show you the differences between glossy and emissive setup. So this one, let me show you what I did. I imported my texture, here it is, and I set the texture precision to be perspective. I tweaked these settings. Then I added a color correction node. I basically messed up with these hue, saturation, gamma values, and then that's it. I basically just applied this, and here you have it. But if you get that same, let's say, glossy material, then you see these are basically identical, and change its type to diffuse, go to your node editor, you can add a texture emission and plug your color correction or even your image texture. You can plug it in this texture emission channel, into the like texture channel, and you can set your power, surface brightness, keep instance power, and then if you apply it and probably turn off the lights, you see that we still can see the wire. We can go even more, maybe plug it in the distribution node too. Yeah, actually it looks better. If you will be using a mission setup, I strongly recommend maybe decreasing the thickness, right? The thing is, it becomes pretty evenly lit, but I like it to be like more lit from one side and blah blah blah. So yeah, then I added another pass of these noise lines, and then another line, and yeah, that's how it is. Also, in the camera, Octane camera, I also repeat this in my every tutorial, but just make sure that you play with these values, because they are really helpful, and you can achieve great results, because that's basically an emulation of your camera. And I'm using a custom LUT here. I upped the saturation just a little bit, exposure, highlight compression, gamma, so all these will give you different results. Also, if you are using, by the way, if you are using this stuff, and you add blue, you can get this kind of cool neon effect. So yeah, alright guys, I think that's all for today, and thank you so much for watching this tutorial. If you find it helpful, please leave me a like, subscribe to this channel, and also check the project files. Link to the Gumroad is in the description. Also, if you have any feedback or recommendations on what things I should cover in future tutorials, please feel free to write it down in comments. I will be sure to check and reply. See you guys on Thursday. Bye.